Hello. Our topic for the project is Tower of Hanoi using data structures. I am Gayatri Vaidya and I am going to start this presentation. Firstly, what is data structure? Our data structure is a storage that is used to store and organize data. It is a way of arranging on a computer so that it can be accessed and updated efficiently. A data structure is not only used for organizing the data, but also used for processing, retrieving, and storing. Tower of Hanoi. A tower of Hanoi is basically a mathematical puzzle that requires moving set of disks of decreasing sizes, initially stacked on one another, using a third peg as an auxiliary. The objective is to transfer all disks to the target peg while following certain rules. That are, only one disk can be moved at a time. No larger disk may be placed on top of the smaller disk. The puzzle has a minimal solution requiring 2 raised to n minus 1 moves, where n is the number of disks, making it an example of a problem solvable through recursive algorithms. We have used two data structures in this. First is stack, and the second is array. Array. Array structure overview. Arrays are used to represent three pegs, A, B, and C. Each peg has an associated array that holds the disk. This structure allows for efficient access and manipulation of the disk during the puzzle solving process. Move functionality. A function is responsible for moving disks between the arrays. The rules of the Tower of Hanoi are strictly followed, ensuring that no longer disk is placed on the smaller one. Complexity analysis. The time complexity of solving the Tower of Hanoi with n disks using arrays is O 2 raised to n. This highlights that exponential growth of operations as the number of disks increases.
Stacks are actually key to solving it in a structured and efficient way. So let's break down how they're used. To start, disk movement management is a central function. In this project, each of the three towers is represented by a stack and disks are added and removed from the top. This setup mirrors the real rules of the game, where only the top disk on each tower can be moved at any given time, keeping the puzzle's constraints intact. Next, stacks help enforce disk order. This structure ensures that larger disks stay on the bottom while smaller disks on top. The stack automatically prevents you from placing a larger disk on a smaller one, which would be an invalid move. This keeps the puzzle rules naturally in place without needing additional checks. Another key point is how stacks simulate recursion iteratively. Traditionally, the Tower of Hanoi problem is solved using recursion, which can be a memory intensive, especially with a high disk count. By using stacks instead, I could simulate these recursive steps iteratively. This not only helps reduce memory usage but also provides better control over the sequence of moves, making the program easier to run on larger disk sets without the risk of overflow. Then there's efficiency. Since stack operations push, such as pushing and popping disks, are quick and straightforward, this structure makes the solution highly efficient. Regardless of discount, each move is simple, ensuring that even a large setup remains manageable. And finally, an extra benefit is the undo feature. I implemented an auxiliary stack to store each move, enabling users to step back and reverse recent actions if they'd like. This can be useful for exploring different solutions or simply as a helpful feature for debugging. So, overall, this project really highlights how Stack provides both efficiency and control in solving the Tower of Hanoi, offering a clear structure and optimized execution for simpler tasks.
Okay, so I will just give it a code overview. So we have used React JS language for coding Tower of Hanoi game and make it interactive and state management. We have also used CSS styling to make it look attractive. So first we had made a static web page with the help of HTML and CSS. Then we converted it into a dynamic web page to make it more interactive using React. The code is simple to understand, and as mentioned earlier by my partners, we have used two types of data structures: array and stack. So as you can see for the array, I have used an example which is initial rod setup as array. So this example actually states that we have used three rods: rod A, rod B, and rod C, and we have used the array part to sort the disk in the descending order. So in this, each rod can be represented as an array that holds disks. Each disk can be represented by a unique number, with small numbers representing smaller disks. This array setup allows you to manage each rod's state individually and perform operations like adding or removing disk. Now for the stack part, we have this is the code. We have used the pop and push methods for this. So it's like we pop up a disk and push it to the other rod. So this function moves the top disk from one rod to another while checking for where it moves. In example, ensuring larger disk isn't placed on a small disk. So this is of it. You can just have a glimpse of it. So next, we have also mentioned the logic of the game is maintained. Logic for where it moves. Then code checks the game is completed. All this on target rod. So yeah, this is the code that if loop where we have rod C dot length equal to 3, which means that the three disk on the rod C is present or not, and in and the proper order. So this is just the photo of the game. It's taken from the Geeks for Geeks, and I will just show you the now code. Yeah, this is a code. The app.js is basically the starting interface which the user gets to see when he enters the web page first. This is CSS styling views. This is the game.js file. This is important file because this is the file which makes the game more dynamic and playful. And this is a CSS file for it. So I will just run for you and just show it how it looks. So npm start. So it's starting. Yes. So we are using visual codes for this. And I just transfer me to the game page here. So this is at a local host. So it's just for the developer purpose. So this is Tower of Hanoi. This is the instructions given. I'll just remove this. So this is the information. You can just have a glimpse of it. Then we will start the game. And as you can see, the game looks like this, and you can play. So I will just show you the steps to solve it. So it's like this. We put it here, number one here, number two, number. So as you can see, we can easily finish this game in 7 steps, and the minimum steps required is 7. So this is the minimum steps, and we for the future purpose, we are thinking to add a leaderboard, number of steps taken, and everything. I hope you liked it.
So, for conclusion, the Star of Hanoi project was completed as a part of our IA2 for data structures, and it really showcased the power and versatility of data structures, especially arrays and stacks, in solving algorithmic problems. Using stacks allowed us to manage recursive operations in an iterative way, optimizing memory usage and control flow. Arrays provided a structured approach to storing and updating disk positions across stars, ensuring each transition stayed organized. This hands on project reinforced core concepts in data structures and recursion, highlighting the relevance of stacks and arrays in tackling complex tasks. Overall, it was an insightful project that gave us a strong foundation in algorithmic problem solving. Thank you very much.